Hello, welcome back to Banana Math, where we're going to explore some more topics in middle school algebra. Today we're going to be talking about simplifying radical expressions. Now, let's quit monkeying around and get to it. Step one, we got to remember how to factor numbers into prime and prime factors. Pretty easy, but let's go over it again. So, we're going to make a factor tree. We're going to start with 117. We're going to see what factors go into it. Right now we can see that 3 goes into 117. How many times does it go into 117? 39 times. 39 factors as 3 times 13. Now we group our primes together that are alike. Here we can count 2, 3. So this number is going to be 3 squared, and our last prime is 13. So this number is 3 squared times 13. That's what 117 is. Moving on to 40. We can see that 40 factors as 8 times 5. 8 factors, of course, again into 4 times 2. And 4 factors as 2 times 2. Now, let's count up the total number of factors that we have that are alike. That, in this case, is the 2s. We have 3 2s. This number is going to factor as 2 cubed times 5. Finally, moving on to 216. Let's factor that one. Ooh, that's a big number. First, we're going to notice that this is 2 times 108. 108 factors again. It goes into 2, obviously, because it's an even number. This is going to be 2 times 54. We can factor 54 again when we see that a 2 goes into it. This is going to be 2 times 27. 27, for those of you who might know, that's going to be 3 cubed. But we'll start by factoring this as 3 times 9, just to simplify things. And we notice that 9 is, of course, 3 times 3. So let's group our like factors together. Here we see we've got 3 2s and 3 3s. This number factors as 2 cubed times 3 cubed. Now we're going to move on to step 2. Let's clean up the board and take a look. We're not going to talk about step 2 in this process. We're going to take the number that we've just factored and we're going to decrease the powers as need be. A couple tools that are going to help us along the way. We're going to remember some properties of exponents. We want to remember that a times b raised to the 1 over m is the same as a to the 1 over m times b to the 1 over m. And just some notation, a to the 1/2 is the same thing as the square root of a to the 1/3 is the same thing as the cube root of a to the 1 over m is the same thing as the mth root of a. So let's take the number that we factored on our last board and take a look at its square root. What might that simplify to? Well, we know that 117, according to our previous calculation, is the same thing as 13 times 3 squared. We're going to take 13 times 3 squared, we're going to split it up into its separate factors, as so. We're going to say that's the same thing as the square root of 13 times the square root of 3 squared. Now we want to remember what the square root is actually doing. It's halving any powers that we have. So in this case we have 2, so I can write this as the square root of 13 times 3 to the 2 over 2. See, it's halving our power here. Well, 2 over 2 is just 1. That goes to 1. 3 to the 1 is 3. And we've simplified our first radical into 3 times the square root of 13. Let's take a look at a couple more examples from our previous board. Here we're going to look at what the cube root of 50 simplifies as. Now we factored it on the last board, so we can write this as, of course, the cube root of 2 cubed times 5. We're going to split this up. This is the cube root of 2 cubed times the cube root of 5. Now we want to remember what the cube root does. It takes any exponent and reduces it by a third. Here we're not going to get any simplification, of course, but here we will. We can write this as 2 to the 3 over 3 times the cube root of 5. 3 over 3 is, of course, 1. 2 to the 1 is just 2, so this simplifies as 2 times the cube root of 5. Now, let's take a look at the cube root of 216. The cube root of 216, as we know in the last board from our factoring exercise, factors as 2 cubed times 3 cubed. Let's split it up as we have been doing. This is the cube root of 2 cubed times the cube root of 3 cubed. The cube root takes any exponent we have and reduces it by a third, so we can write this as 2 to the 3 over 3 times 3 to the 3 over 3. Those both cancel the 1. We've got 2 to the 1 times 3 to the 1, which is just 2 times 3, and this is equal to 6. Okay, so now to continue, we want to ask the question, when is the mth root of a to the n simplifiable? I kind of glossed over this, but for example, what if we have the cube root of 2 to the 2th power? Well, that's 2 to the 2 over 3. And unfortunately, when 3 does not go into 2, even at least once, there's nothing we can do here. But there is something we can do with the cube root of 2 to the 5th. And it's not immediately clear why. Because this is equal to 2 to the 5 over 3. Here we get another fractional expression. What can we do here? Well, the answer is we can get further simplification when m goes into n at least once. Now, that may be a little confusing, but let's take a look at what that means. It's actually pretty simple. Okay, so first, what does it mean when we say m goes into n at least once? Well, let's talk about the symbology first. We want to write an expression, n, where we write it as m times some natural number k plus some remainder L, where L is less than n. Now, that's a lot of detail we don't need to go into. But simply put, let's say I want to know how many times does 5 go into 3. Well, 5 goes into 3 at least once, where we can write this as 3 times 1 plus 2. Where we say, hey, it goes into 3 once, goes in once, and we have a remainder of 2. So this is really just some elementary arithmetic. We're just reintroducing it here. Okay, so now how do we apply it to our situation? Well, we will also want to remember this property of exponents when we're utilizing this feature. And we want to remember that a to the n plus n is the same thing as a to the m times a to the n. We're going to see how this plays into it in just a second here. But let's go back to our example. We're going to write the cube root of 2 to the 5. And we're going to just start rewriting it like we've seen. We're going to write this as the cube root of 2 to the 3 times 1 plus 2. Remember, goes in once, we have a remainder of 2. Now, why do we want to write it that way? Well, let's break it up like we should down here. We're going to write this as the cube root of 2 to the 3 times 2 to the 2. Pretty simple so far, right? Okay, so why do that? Hey, look, we can write this now as, I'm going to distribute this cube root to either side, which means take a third of both of these exponents. So I can write this as 2 to the 3 over 3. Hey, that's just 1. We got some simplification there. And this is the other part we can't simplify. It just simplifies as 2 to the 2 thirds. But at the end of the day, we can get more simplification, and finally write this as 2 to the 2 to the 2 over 3, or 2 to the cube root of 2 squared, or 2 to the cube root of 4. And that's our final answer for this particular problem. Please comment on any other problems that you'd like me to talk about, and have a fantastic day.